So a hormone is a blank and a target cell is a blank. What is a hormone? Yes, this is a molecule that has a metabolic effect on another cell, and it has a receptor for a specific function, right? This is the equivalent of thyroid stimulating hormone binding to what? Thyroid stimulating hormone receptor. The hormone binds to the receptor, and then there's an effect. Secretions that affect only nearby cells are termed exocrine, endocrine, autocrine, or paracrine. Para, right? Para means beside. Auto means what? Self. Endocrine means. What if I give you a question that's talked about the pancreas, and I said the pancreas had both endocrine and exocrine functions, and then I talk about maybe a hormone lipase, and I said it was secreted through a pancreatic duct. Type of, would that be autocrine, endocrine, exocrine, or paracrine? Why would that be exocrine, Jared? Right. Everybody hear that? That one might be important. Could be maybe a test question coming up. I don't know. But the pancreas has both endocrine and exocrine functions. The endocrine functions, what are the endocrine functions? What hormones are secreted there? What does a pancreas produce? Insulin and glucagon, right? Insulin's produced by what cells? Beta. Insulin is secreted. I'm going to repeat that again so everybody knows. Insulin is produced by the beta cells, okay? Glucagon is produced by what? The alpha cells. Cool. Those are the endocrine functions of it, okay? The exocrine functions are going to be the digestive functions. They're secreted through ducts, so we know they're exocrine in nature. What about this number 3? He gave a crazy question. During early embryonic development, a protein called sonic hedgehog, does that even matter what the protein is? No. That is a real protein, though. Weird. Is released from a cell and travels through the interstitial fluid to nearby cells. You should already be cluing in on what the answer is, nearby cells. This helps to establish the path and direction of development for the nervous system and limbs. Knowing this, sonic hedgehog must be a what? How do you guys know that it's paracrine? Nearby cells, right? What if I would have said cells at a distant site? Or endocrine, right? Endocrine. Yeah, exocrine. I just think duct or lobule, right? How do exocrine glands differ from endocrine glands? Number 4. Yeah, exocrine glands secrete through ducts or tubes to a free surface, right? So number 4 is B. Now we're getting into the different types of hormones, right? Which of the following is true for steroid hormones? The receptors are found on the cell membranes of target cells. Is that true? They circulate free in the blood, not bound to any carriers. They are soluble in lipids, or they include epinephrine and norepinephrine. Yeah, they're soluble in lipids. So, because they're soluble in lipids, what can they directly do? Yes, they bind and they cause an increase in gene expression. So, let's say, for example, I don't know, there was a female who didn't develop secondary sexual characteristics. She's missing a hormone. They give her a drug that works like estrogen. So how would it work? Yes, because estrogen's what? Estrogen's a steroid, right? It's lipid soluble, therefore it can directly affect gene expression. Does everybody understand that? What if I said testosterone? Would that change anything? No. The secondary sexual characteristics, right? So we know that steroids can directly cross the plasma membrane. That was the whole point of that question. So can non-steroids do that? So how do non-steroids work? Right. They have to have what? A secondary messenger. So do you guys remember that whole cascade of adenylate cyclase? Right? Adenylate cyclase causes an increase in cyclic AMP. All I want you to know is that buzzword, adenylate cyclase. It stimulates adenylate cyclase, okay? Knowing that it's a product of a secondary messenger. Where are hormones secreted by the posterior pituitary synthesized? This might be a trick for you guys. Yes. Posterior pituitary hormones are synthesized in the hypothalamus, right? That's just a recall question. What controls most hormone concentrations? How does homeostasis, by what mechanism does homeostasis exist within our bodies? I told you guys this. Negative feedback. That's exactly the answer. So most hormone concentrations are regulated by negative feedback. There's only 2 examples I can think of positive feedback. What's one of them? Oxytocin, and what's the other one we just discussed? Phthalate surge with ovulation. Those are the only two I can think of. What is the action of growth hormone?
The tip of cells divide and grow.
Yep. Increase in mitotic activity, absolutely. What did I say here?
What was number 9?
Number 9. So the question is, what is the action of growth hormone? What stimulates the reabsorption of sodium? Who does that? Kidneys do. What hormone? You guys remember aldosterone? Where's aldosterone produced? Salt, sugar, sex. So the adrenal cortex, right? What layer specifically? This might be important for an exam. Go fetch Rex. Granulosa, right? Salt, sugar, sex. Go fetch Rex. Salt is the reabsorption of sodium, so that's the zona glomerulosa. The fasciculata is what? Sugar, that's cortisol. And what's sex? The androgens, right? That's the reticularis. So aldosterone primarily, the one I'm wanting, might be a test question coming up. Maybe a synthetic drug that mimics the a hormone in the kidney that reabsorbs sodium and secretes potassium. Which of the following would have an increase in mitotic activity? The glomerulosa, right? Glomerulosa. You guys get that? What is the action of aldosterone? Well, let's go through these. Oh, you're right. What's the enhance the movement of amino acid into cells? Growth hormone do that? Yes, it's used for protein synthesis, right? It's on that picture of that slide. Increase in protein synthesis. Increases mitotic activity. So when things grow and divide, they have to have fuel, which means they have to have protein synthesis to occur. Okay? Might have been a hard one. It's not on the exam. Decreases the rate at which the body uses fat for energy. That's an oddball. You guys wouldn't know that one. What increases the rate of carbohydrate use? What do carbs get broken down into? Sugar, right? Sugar. And who is responsible for raising and lowering the blood glucose? Anti-inflammatory properties. Which one? Yeah, that's right. I give somebody a synthetic drug, cortisol. I give somebody has a gout flare-up, and they get prescribed a drug, and its drug properties are, one, they reduce anti-inflammatory, or they reduce inflammatory mediators, and 2, is a side effect that raises blood glucose. What hormone does that drug work like? Cortisol, right? Cortisol is anti-inflammatory, and it raises blood glucose levels. I would know that. So number 10 is increases the rate of protein synthesis. Growth hormone increases mitotic activity and increases the rate of protein synthesis. A female patient is experiencing a hormonal imbalance that results in low estrogen production, causing her to skip menstrual periods and to not ovulate. Which of the following is the most likely imbalanced hormone? So she's got low estrogen. As a result, what's elevated? GnRH would be on there, right? FSH. Who said that? Yes, FSH, right? Both as a result, right? GnRH would raise, which would cause an increase in FSH. So I wouldn't put both of those on the exam, though. When would ACTH levels be elevated? What gland would have to be messed up? The adrenal gland, right? That's Addison's disease, right? When the adrenal gland stops working, ACTH levels rise. Growth hormone, don't worry about that one. There's not really a pathology that can happen. Where are the target cells for hypothalamic releasing hormones located? So after the hypothalamus releases hormones, where are the target cells? Which one? Anterior or posterior? Well, that's true. That's a good point. Anterior pituitary gland. I didn't give a specific one. I wouldn't put posterior on the test for you, though. I would just either put anterior. I would just put one of the two, right? Because technically, I guess that could be A or B. What hormones are released from the posterior pituitary? Is oxytocin only, ADH only, oxytocin and ADH? Oxytocin and ADH. What does oxytocin do? What's the whole? If I were to say that we give a woman who is in birth, we give her oxytocin, what would the purpose of that be? Yeah, stimulates uterine contraction. Do you know what that is? There's actually a drug they give women in pregnancy called Pitocin. Anybody ever given birth, they may have gotten a Pitocin injection, right? And what that does, Cody shakes his head like, no, I've never been in birth. But Pitocin, it goes and it binds to the uterus and causes it to contract, helps them with pregnancy. Jerry drinks a few beers and soon has to urinate. What effect did alcohol have on hormonal control of urination? What do you guys think? What is responsible for causing us to pee and not causing us to pee? ADH, antidiuretic hormone, right? So it inhibited the secretion of ADH, right? So ADH is normally going to conserve water. Why is oxytocin administered to women during childbirth? I must have thought that was a good exam question because that's on the exam, right? So oxytocin is going to stimulate uterine contractions, okay? Y'all want another softball? Here you go. There's a 18-year-old male who presents to his physician, and he's noted to have an increase in hat size. He's grown 18 inches within the last month. Which of the following would you expect to be found within this patient? So what hormone do you think is elevated in this man already? Growth hormone. Growth hormone is elevated, right? Does anybody know the name of this pathology? Gigantism, right? Andre, I even put his name as Andre for you guys. Andre the Giant, right? Anyways, he's got an increase in growth hormone. Does anybody remember the name of that little mediator protein that growth hormone binds to and causes an increase in the level? I said to know this one. IGF-1, insulin growth factor 1. So as a result of growth hormone binding to the receptor, you would also see increased levels of IGF-1.
That's its target too.
Yep, that's its mediator protein, right? Growth hormone binds to the growth hormone receptor and thus causes an increase in IGF-1.
IgA?
Yes, insulin growth factor. So in number 17 on the practice exam, it says growth hormone stimulates the release of A, IGF-1, B, PTH, C, FSH, or D, TGF. So which one would it be? IGF-1. So if a guy had a tumor producing too much growth hormone, would it make sense that IGF-1 would also be elevated? Yes.
What was 16?
Sorry, 16. Oh, here you go. Growth hormone signals the release of IGF-1 from the liver. It's on that slide talking about growth hormone and IGF-1 interaction.
So IGF-1's in the
Yes.
So release from the liver.
Yes. How do the hormones of T3 and T4 differ?
T3's active.
Yes. Is T4 more potent than T3? No. T4 is converted to T3 in peripheral tissues? Yes. What's the name of that enzyme? Does anybody remember? 5-deiodinase. You guys don't have to know that. So T4 is converted to T3 in peripheral tissues. Okay. What endocrine gland secretes T3? Adrenal gland, parathyroid, thyroid, or pancreas? T3, thyroid hormone. Same thing as thyroid hormone, right? So it's secreted by the thyroid. Where is thyroid hormone stored? Thyroid gland. Remember, what's the name of those structures in the thyroid? Follicles. Follicles, right? Ricky Joe has a very high metabolic rate. He's skinny. It's noted that he has a disorder of thyroid metabolism. He's in his peripheral tissues or in his blood. They notice that there's an increase in T3 and T4. Which of the following would you be expected? What are the levels of TSH if T3 and T4 is elevated? Negative feedback, right? It'd be low. So if T3 and T4 is elevated, TSH, as a result of that, because of that negative feedback, TSH has to be decreased, right? What condition does he have? Hyperthyroidism. So 20 would be D. What is the action of thyroid hormone? Yep. So to inhibit response of the nervous system? No. To inhibit the rate at which calcium enters body fluid? No. What regulates calcium? Calcitonin and what's the other one? PTH, right? Parathyroid hormone. To reduce the rate at which carbohydrates are utilized? No. To enhance the rate at which proteins are synthesized? Yes. Because it increases metabolism, right? Protein synthesis, this is all metabolic. What happens if parathyroid's not working in 22? Parathyroid normally does what? Causes an increase in what? Calcium and phosphorus, right? So if parathyroid's not working, what would you expect it to be? Low calcium, right? Low calcium and phosphorus. So the amount of calcium in the blood will increase and the amount of phosphorus in the blood would decrease as well. What's the primary control of secretion of the parathyroid hormone? It's the amount of calcium present, right? What hormone stimulates calcium deposition into bone? Sorry. So if parathyroid hormone's not working, the levels of calcium and phosphorus will both decrease. What hormone stimulates calcium deposition into bone? Is it thyroxine? Is it insulin? Is it calcitonin? Or is it parathyroid? So PTH removes it from bone, right? Calcitonin deposits it. Yes, C. Which of the following is a hormone secreted by the adrenal medulla? Epinephrine, glucocorticoids, aldosterone, or mineralocorticoid? Epinephrine, right? Those are catecholamines, epinephrine, norepinephrine. It's just comes down to the structure of the gland and where they work on receptors. You remember back in autonomic nervous system, there's beta 1 receptors. Epinephrine primarily works on the beta 2 receptors. Beta 2 is going to be present in the lungs, causes the lungs to expand. Norepinephrine primarily binds to the blood vessels, causes them to clamp down, vasoconstrict.
So which would be used in, say if you're was it adrenaline that's used for your heart stopping essentially?
Yeah.
Is it norepinephrine?
So there's two different types. Let's say that you're going to go into anaphylaxis, right, where you're having a bad allergic reaction. So they'll give you an EpiPen and cause your lungs to dilate. If you need your blood pressure to raise, let's say that you're crashing, they may give you Norepi. So two different things. What is the action of cortisol? It's anti-inflammatory, right? Also stimulates the production of glucose from non-carbohydrates.
That was 26.
Sorry, aldosterone promotes the homeostasis of ions, causing the kidneys to. What does aldosterone do? Right. So it conserves sodium and excretes potassium, increasing the blood pressure. Yep. So 26 is B. So what is the action of cortisol? We said it's C, to stimulate the production of glucose from non-carbohydrates. What is the action of insulin? Yep, lower blood glucose. So decreased concentration of blood glucose. Cody has been working at the hospital. He usually works day shift. Got switched over to nights. He's having trouble sleeping. I give him a hormone that's produced by his body that works to help regulate his sleep cycle. Where's this hormone produced? Pineal gland. What hormone am I talking about? Melatonin. Cool. Describe the composition of semen. It contains secretions from interstitial cells. It is acidic. It includes prostaglandins and nutrients. It contains 100 mature sperm. C, prostaglandins and nutrients. Yep, has fructose in order for it to survive. Why does it need fructose to survive? How does the sperm, softball question, you ready? There's a scientist and he's performing an experiment about ATP production within the sperm. He is trying to study to see where most of the ATP is produced. He uses an enzyme. Which area would you expect to see the most ATP production? Is it the head, the midpiece, the tail, or the neck? Yeah, why is it the midpiece? Yeah, the midpiece has all the mitochondria. And what's the mitochondria responsible for? Yeah, everybody says the mitochondria is the what? Powerhouse of the cell. What is most of our energy? Where do we get it from? ATP, right? ATP is produced from the mitochondria. So he's doing this experiment. He's trying to figure out where ATP is produced within the sperm. It's in the midpiece. Why? Because the midpiece contains the mitochondria. Does everybody understand my reasoning for that? Softball, it's coming. What structures do the sperm enter upon exiting the epididymis? It's a mnemonic question. Yep, vas deferens, 7-up, right? Seminiferous tubules, epididymis, vas deferens, ejaculatory duct, nothing, urethra, penis. Does everybody know that mnemonic? What structure does the sperm enter upon exiting the ductus deferens? So where's it going after the vas deferens? Ejaculatory duct, right? B. Where do sperm cells mature? In the epididymis. 33 is C. Male reproductive functions are controlled mainly by hormones from the hypothalamus in what two structures? So you got LH and FSH coming from the, where? Anterior pituitary. Where's testosterone coming from? Testes. So anterior pituitary and testes. What comes from the posterior pituitary? ADH and oxytocin, absolutely. What hormone is responsible for development and maintenance of male secondary sexual characteristics? Testosterone, LH, GnRH, or FSH? Testosterone. What stimulates the release of testosterone? Decreased plasma concentrations of FSH, increased plasma concentrations of LH, increased plasma concentrations of FSH, or decreased plasma concentration of LH? Increased LH, right? Increased LH causes an increased production of androgens. Does anybody remember the name of the cells where they're produced? Where LH binds? Yep, the Leydig cells. Cool. And which cells are responsible for spermatogenesis? The starts with an S. Remember FSH. Sertoli cells causes spermatogenesis. You guys remember that mnemonic? FSH causes the Sertoli cells to undergo spermatogenesis. During what stage do sperm change from a haploid to a diploid state? Or sorry, from a diploid to a haploid state. Yep, or secondary spermatocyte, right? It's from that primary to that secondary spermatocyte change. Klinefelter's is a disorder in which there is little to no testosterone production. Based on your knowledge of the hypothalamic pituitary axis, which of the following would you expect? So if there's low levels of testosterone, what has to be elevated? So is it elevated LH, elevated ACTH, decreased prolactin, or decreased GnRH? So increased GnRH if that were an option, but what does GnRH cause an increase of? LH, right? So it's increased LH levels. Which of the following is a cause of decreased fertility? Loose underwear, decreased testicular temperature, elevated testicular temperature, or increased Viagra usage? Increased testicular temperature. Okay.